Alright, so we are finally going to start working with graphing, and we're going to start today with 4-4, points on the coordinate plane. So a regular coordinate plane we call the Cartesian plane, and it's named after a dude named Descartes, and we're going to talk about him in class a little bit. But he actually discovered a way that you could actually label points, and it became really useful for a lot of different things that we'll talk about. So let's get some vocabulary down that we need. So this is the Cartesian plane. You've seen this before. The horizontal line here we call the x-axis, and the vertical is going to be the y-axis. If you ever get those confused, I want you to just think about the fact that yo-yos go up and down, right? So the y-axis is going to be up and down. Railroad crossings are horizontal. You don't have railroads going up and down. So that. Okay, the point right in the middle we call the origin, and that point is going to be, I'm going to label that as 0, 0, meaning that's our starting point. We haven't gone anywhere yet, and that's right square here in the middle. So when we are labeling points, we call them coordinate points. And when we have those, they're always going to be listed as your x coordinate first, and then your y coordinate. If that's confusing to you, it's alphabetical. X comes before y, right? So let's do a few different versions of that. So let's say we have point A, and we've got, let's say -4, +3. So I'm going to always start at the origin. Let me do this. So this is positive. We know from our vertical number line, going up is positive, increasing is positive, decreasing is negative. On a horizontal number line, we know this is going positive to the right, and going to the left is negative. So this tells you what direction to go. So we're going to go to the left, 1, 2, 3, 4, and then from that point we're going to go up 1, 2, 3. So this would be point A. Point B, let's say that's 2, -5. So from there we're going to go over 2, 1, 2, and down 1, 2, 3, 4, 5. That'll be point B. Point C, let's use points 3, 4. Okay. So now we're going to go over 1, 2, 3, and up 1, 2, 3, 4. It's going to be point C. Then point D, let's go -6, -8. So we're going to go over to the left now, because these are negative. To the left, 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5, 6, 7, 8. Right there. So point D will be right there. So there's some things that go on. And these different sections of the Cartesian plane actually have a name. They're called quadrants. Okay. So this first one here is quadrant 1. Okay? And in that quadrant, our points are going to be positive and positive. The quadrants go counterclockwise, so the ones at the top left will be coordinate 2. And in quadrant 2, all of those points are going to be negative and then positive. We go to the left, and then we go up for all of these points. In quadrant 3, both coordinates are negative. We go to the left, and then we go down. So we have negative, negative. And in quadrant 4, Roman numeral for 4 looks like that. And in this, our x-coordinate is positive, and our y-coordinate is negative. We go to the right, and then we go down. Okay, so there's got the basics of plotting points, and we'll do a lot of practice on that in class, so it becomes really easy for you. So let's zoom in a little bit here. So we can see the points on this graph. So we're just going to, from this graph, see if we can pull some of the points that we see. So anytime something crosses a line exactly at an intersection of one of those little squares, we want to use that, because that's definitely easy. So, and then we're going to see where that dark line intersects right on the corner of one of those squares. Okay. So let's see, let's go up here. Right. So we've got 1, 2, 3, 6 good points that we've got there. So let's do 6 coordinates. Okay. And so let's see. Let's start with our first one right here, which will be at 0. I haven't gone anywhere left or right. I'm just going straight up. So I would have a 0 for my x-coordinate and 1, 2, 3, 4 for my y-coordinate. Let's go over here to the left. So I go over 1, 2, and I go up 1, 2, 3, 4, 5, 6, 7. So I'm at -2, +7. And if I go over again, now I've gone over 2 more. I was at 2, 3, 4. So at -4. And I was at 7. Now I'm going up to 8, 9, 10. Oh, it should be +10, not negative. Okay. Now let's go to this side of the line. So I was at 0, 4. Now I'm going to come over here and I have to go over 2 and up 1. And then I go over 1, 2, 3, 4 and down 1, 2. So that's going to be 4, -2. And then over 2 more. So it's 6, -1, 2, 3, 4, 5. Okay? So one really important idea I want to talk about is the idea of an initial value or a starting point. And that starting point for any of our straight line graphs is always going to be on the y-axis. And we call that the y-intercept. You can also call it the initial value. That's what it represents. It represents the initial, where did you start? Okay, so in this case, our initial value was at 0, 4, or our y-intercept. It's wherever your line crosses the y-axis. And when we start graphing in slope-intercept form, what I like to have you do is have you highlight the y-axis so that your first point is always on that line. Okay, it will really help you in the future when you are working on slope-intercept form, which is coming in the next unit. Okay, so let's talk about a situation here. So Sarah has 2 baseball cards. Each day she collects 3 more cards. So let's give these a label. So we were talking about 2 things. So the period of time that's going by are days, right? And the things that she's collecting are cards. Okay? So, and this is going to be, she has 2 baseball cards. That's going to be your initial value, how much you're starting with. Okay? So before any days have gone by, she's got 2 cards. Then every day she collects 3 more. So here she's going to collect 3 more. So 2, then she gets an additional 3. She has 5. On the second day she gets 3 more. That gives her 8. And on the third day she gets 3 more. That gives her 11. So it is possible for you to actually write an equation based on what's going on over here. Right? That every day she's adding 3. So we know that she starts with 2. And then she is increasing by 3 per day. So the way we can write that is 2 plus 3 times the number of days that go by. So then you can ask yourself, okay, well if, let's say 2 weeks goes by, right? And after 14 days, how many cards would she have? Okay. Well, we know that she starts with 2, and they know for 14 days she gets 3 more cards every day. So 3 times 14 is 42. So after 14 days she would have 44 cards. And the way you would write that coordinate point is 14 is the number of days that went by, and she would have 44 cards when she's done. Each of these can be written as a coordinate point. So you would have 0, 2, 1, 5, 2, 8, and 3, 11. And then if we come over here to graph those points, we would have 0, 2, that's what she started with, and every day is the number of days that goes by, and so this is our x-coordinate, and our y-coordinate is our number of cards that she has. 0 days, she has 2 cards. At 1 day, she increases that by 3. 1, 2, 3. So she's at 1, 5. After 2 days, she has 3 more cards, and that's 1, 2, 3. Now, in real life scenarios like that, you're not going to have any negative inputs because you can't have a negative number of days go by. So all of your points would be just here in quadrant 1. Okay? Good. Okay, so then sometimes you need to see if a specific point is the solution to an equation. And remember, you're checking to see, does this input give you this output? So if I put this number in, do I get this number out? You can think of it like a machine, right? And depending on the machine, it should work the same for every number that you put in. So let's check y equals negative 2x plus 3. So now you're going to plug in 5 and 8 in where you have an x and a y. So our y value is 8, and that should equal negative 2. Our x coordinate is 5 plus 3. So 2 times 5 is 10. It needs to be the negative of that, which is negative 10 plus 3. Well, does that equal 8? Nope, sure doesn't. 8 does not equal negative 7. So this is not a solution to that equation. Okay? Let's figure out what some solutions would be. So we always know that this number that stands alone, that is going to be our initial value, or our y-intercept. Okay? So we always can start with that. So in this case, we know that's our equation. Let's just start with that. So then if we plug in a 1, we have y equals negative 2 times 1 plus 3, which gives us negative 2 plus 3, which gives us 1. So when we input 1, we get 1 as an output. When we plug in 2, we get negative 4 plus 3, which gives us negative 1. So your numbers, each time, what are they doing here? They went down by 2. From 1 to negative 1, we went down by 2. This number in front of the x always shows you your rate of change, or your slope. So everything on that line should be changing at the same pace. So we can actually go through and just keep decreasing these by 2. For every one step that it's increasing in your x column, it's decreasing by 2 in your y column. And then we can graph those points. So we have 0, 1, 2, 3, 1, 1, 2, negative 1, 3, negative 3, 4, negative 5. Oh, that's right. And 5, negative 7. And there's our nice straight line. We are good to go. Okay, so then I want you to, below, fill in the table from this graph and see if you can come up with an equation that looks something like the one we came up with here. Okay, so once we pull all of these coordinate points, these are the outputs that we get. We have negative 3, negative 4, negative 2, negative 2, negative 1, sorry, negative 1, 0, 0, 2, 1, 4, and 2, 6. So we know this one that sits on the y-axis is going to be our initial value, or our y-intercept. So that's always going to be what we start with. We start with that 2. And then you just have to look to see every time you move up by 1, and we can just use the positive numbers because we can see it's doing the same thing. It's increasing by 1. Then on the y side, it's increasing by 2. And that will be consistent through the whole thing. So you have 2 plus 2x. If you're going to put that in true slope-intercept form, you would write it as y equals 2x plus 2. Well done. That's the end of Unit 4.